Hi, this is Jane Schutskoff. I work for RA Hoy Heating and Air Conditioning in Kitty Hawk, North Carolina, and I'm going to present to you why does my ductwork sweat? All right, so just to give you some insight of our climate, right? You really have to understand where we're at. So we are located Outer Banks, North Carolina, right on this edge, and it is red. So to kind of compare, is you look down south and you got the state of Florida, which is solid red. So we actually have the exact same humidity level as Miami, Florida would in the Outer Banks. To me, this is pretty crazy. That's extremely different from the rest of North Carolina state. There's actually 5 different climate zones, even though you can't see it on this picture. But we're the most humid in the state of North Carolina, which to me is just insane. So I actually wanted to do this presentation kind of in a timeline fashion from failure to success and how we kind of got there and the research that it took to get to the point where we're at. So I'm going to share with you a few mistakes that I made and a few things that we attempted to do as a company to try to solve these issues. So first thing we thought when it came to condensation issues was the ductwork leaking. So we thought that there was air infiltrating from inside the ductwork to the outside, which is just through a gap, just air pushing out. This is cold air hitting the outside of the ductwork. Boom, causes condensation, and now we have sweating ductwork. So we actually bought an air seal machine to stop the leakage inside and seal up all the ductwork. But even with the proven test, we still found out that the ductwork did, in fact, still condensate. So that was a pretty big fail for us to do. So first thing we tried to do after this was adding a fan to the area. We thought it was humid and we thought the area was actually hotter than what it was, and we thought that we need to cool down the ductwork. So we sat there blowing down air on our duct system, and in attics it actually made it worse. In crawl spaces it didn't really do anything. So that idea was also a fail. All right, so the last idea we had to fix the ductwork condensation issue was to go ahead and wrap the ductwork with more insulation. So typical duct system trunk line in an unconditioned area is R8. So we thought, let's go ahead, rip the vapor barrier off of another sheet of R8, and let's go ahead and wrap the ductwork again to form R16. So we're thinking doubling the code, we should be able to double our chances and not have any issues double wrapping this trunk line and forming a really big insulation blanket around the cold duct system. This did help, but it did not stop our condensation from happening, which that's what we're trying to achieve. We're trying to stop condensation from forming on the outside of the ductwork. So this also was a fail. All right, so after failing multiple times and not being able to successfully stop the condensation from forming on the ductwork, we really sat back down and put our heads together and started doing some research. So the things I'm going to go over that you have to understand to where we got our research from is you have to understand air temperature, you have to understand R value, and you also have to understand dew point that's inside the air. So those are 3 key factors that causes condensation to form. All right, so first one's pretty easy. It's temperature, temperature of an object, how we measure the hotness or coldness of matter, whether it's air, liquid, or solid. So that's a pretty easy one that everyone understands. All right, so second key factor is R value. Understanding R value is practically the more R value you have, the more insulation you have. So you want R value. You want to slow down the amount of heat on one side of this wall to the other side of this wall. All right, so the last factor I want to describe is dew point. Dew point is very hard to understand sometimes. It's just confusing to some people. So if I had a 60-degree dew point, all right, 60-degree dew point, so anything below 60 degrees is going to condensate. So if I took a can of cold Coke out of a fridge and put it on the counter, there would be condensation on it because that can of Coke is probably 35 degrees Fahrenheit and the dew point 60. So 35 is well below 60. But something that's above 60 degrees won't condensate. So dew point is the point on when an object will start to condensate. All right, so after figuring out our key factors and understanding air better, I started to draw out the scenario. I wanted to draw out all the temperatures inside of this issue that I was having, which ended up being a crawl space issue. The one I'm talking about specifically was a crawl space issue. So I drew, the crawl space here. Here's the top of the house. And there's actually a garage beside it. And then here's the ground. And this was an open crawl space. So I got this ground temperature from Googling Earth's temperature. I already knew this prior just from my HVAC experience, but the next slide is going to show you all the data I grabbed from. All right, so I just went ahead and I just typed into Google Earth temperature, approximately 59 degrees. I ended up rounding up to 60 degrees on my drawing, but 59 degrees, 60 degrees, it's practically the same temperature. All right, so after figuring out Earth's temperature, which is pretty easy to find, I needed to find the Outer Banks weather conditions. So what I did is I actually researched and found out that you can look up www.wonderground.com, history, monthly, U.S., North Carolina, Kill Devil Hills area is where I got this data from, which was actually from the airport, which they take measurements all the time. And I was able to pull temperature and dew point from the area. So I used the data of this. This is a screenshot of I put Kitty Hawk on here, but it's really Kill Devil Hills. So I went ahead and took a screenshot, and right here is the average temperature. This is the month of August, by the way. So it's the average temperature of August in Kill Devil Hills is 79 degrees is what I found here. So this is the number I use practically. So I went ahead and marked on my drawing here 80 degrees Fahrenheit for outside temperature. So this right here is my outside temperature. Now the next thing I need to find out, from my experience of crawling in crawl spaces are always cooler. So I went ahead and researched the crawl space. What is the temperature of a crawl space? I went ahead and Googled temperature difference of open crawl space. Specifically, this was an open crawl space. In a crawl space in the summer months, there is HVAC ducting in the crawl space. We normally see temperatures ranging from 70 to 75 degrees. So I went ahead and used 70 degrees as my crawl space temperature. All right, so now that I have 80-degree outdoor temperature, goes through the crawl space, all right, the outside temperature or ambient temperature turns to 70 degrees. All right, so now I got two factors in here on what's happening into this crawl space in my surrounding area. So the next factor I got to find out is what's the temperature of my air? What is the temperature of my supply duct? All right, so even though I already knew the answer to this question, I went ahead and Googled it anyways. So I typed in typical cooling delta T of an HVAC unit. And what that really means is the difference between the return and the supply. So typically you find 16 and 22 degrees Fahrenheit. A lot of our systems that we put in, typically we end up around 20 degrees Fahrenheit. So in easier knowledge, if you put your thermostat to 70 degrees Fahrenheit, more than likely your supply air is going to be 50 degrees Fahrenheit. So I went ahead and used 50 degrees Fahrenheit as the temperature inside the ductwork. All right, so I went ahead and added the supply duct here. So right here is my supply duct. It's 50 degrees Fahrenheit. I kind of explained the last bit, typically where we set the thermostats to get 50-degree Fahrenheit. So our next step is going to be, what is the dew point? What is the dew point of this crawl space here? All right, so this is August month, or the month of August in Kitty Hawk. So the average dew point in Kitty Hawk is 70.37 degrees Fahrenheit, which is crazy because any object below 70 degrees Fahrenheit will condensate in Kitty Hawk. That's on average. So we actually have maxes as high as 82 degrees and mins as low as 49, but our average really is 70.37, which is most of the time. All right, so went ahead and added dew point to our illustration here. So went ahead, here's dew point, 70 degrees or lower. Here's a supply duct, 50 degrees. This is our crawl space temperature of 70 degrees and our outside temperature of 80 degrees. So we're starting to kind of build a diagram here. So the next diagram we're going to do is going to be what is the insulation around our ductwork, which is going to be R8, but what is the temperature of that insulation? That is a key factor here. All right, so I took a snippet from the North Carolina State Code, North Carolina State Energy Code. of unconditioned spaces. So supply and return ducts in unconditioned spaces and outdoors shall be insulated to a minimum of R8 ductwork, which is what we do. This is what we wrap our ductwork with. So I go ahead, I add my insulation R8, I add it around the supply duct, but I still haven't figured out what is the out temperature, what is the outside temperature, what is the temperature of the edge of this, because that's what's condensating. It's not inside the ductwork, it's on the outside of the ductwork. So what is that temperature? I'm going to show you a formula on the next slide on how I got to there. All right, so I actually pulled this spreadsheet or this formula from Train Comfort Site, which all our dealers have access to this, and if you're a Train dealer, you have access to this. So I went ahead and you plug in some formula numbers here. So I went ahead and in our air temperature in the ductwork, it's 50 degrees Fahrenheit. So that's our supply air temp. So then our ambient air temperature, which is our crawl space temperature of what I'm drawing, was 70 degrees. We all decided that as well. In our R value, we wrapped the ductwork with R8, and then this all formulates and ended up showing us that the duct outer surface temperature, which is extremely important, this is what I was trying to find, what's the temperature of our ductwork, or the outside of our ductwork, is 68 degrees. And on the next page, you're going to see that what happens when you have a 68 degree object in a dew point that is set to 70, that 68 degrees is colder than the 70 degree dew point, which will condensate. All right, so let's just run through this real quick. So we got an 80 degree outside temperature, right? We got a 70 degree in the crawl space because the air cools down from the earth temperature here. The dew point inside this crawl space is 70 degrees. We got a 50 degree supply. We have an outside temperature here that is 68 degrees. We just figured that out on the last sheet. So when this number is lower than this number here, you get this, condensation. So at this point, after figuring out I can control this, I can control this, the one thing I can't control is dew point. So if I can control dew point, I can control this entire issue right here. So I just want to go over some of the solutions on why they failed. And just to give you a better understanding of why I don't want you to do some of the solutions that are here, because I've been talking to plenty of the issues just because it's really hard to understand and it seems like it should be easy to fix. All right, so the ductwork must leak, seal the ductwork up. So this is when we went ahead and tried to aero seal and why this failed. We went ahead and we aero sealed this duct system and we got down to 2% leakage. So that's a sealed duct system. North Carolina State Code is 5%, but we got down to 2%. The condensation did lessen, but it still formed. It did not stop the condensation from forming because the outside of the ductwork was still 68 degrees. All right, so on this slide here, we went ahead and we added a fan to the crawl space, I guess hoping that you could take that 80 degree Fahrenheit air and add a little bit more heat to that crawl space to get maybe the ambient temperature up, which we did get it up, but still was not. So we still found that the condensation lessened, but it never really fixed it. So this is the exact same formula that we ran before. So here's our 50 degree supply air. Here's a 72 degree ambient, which is 2 degrees higher. And here's our R8, and here's our duct outer surface temperature was 69.8. So we raised it a good couple degrees, but it was still running the fan all the time. So unless you want to run a fan underneath your crawl space 24/7, I don't advise using this solution. All right, on this one was a pretty good idea, I thought at the time, even though it was crazy. But when we went ahead and we wrapped the ductwork with double the amount of insulation, so we went ahead and double wrapped this to form R16. It really didn't help us at all. One thing, it's ridiculous because it looked like a pillow. So you had 4 inches of thick insulation going both ways, which the ductwork looked massive. I mean, a lot of places you can't even fit ductwork like this. We just knew it wasn't a real solution, but because it was a crawl space at the time, we had the height to do this. But it still didn't fix the condensation issue. So the crazy part about this is I ran this through the formula, and this is what kind of surprised me the most. So we have an air temperature of 50 degrees, and we have the ambient temperature of 70 degrees, right? Those are the exact same. But here I went ahead and did the duct wall R value of R16. So that used to be 8, but we ran it to 16. And the outer surface temperature only went from 68 to 69 degrees. So it only changed by 1 degree, and that's why the ductwork still ended up condensating after I went ahead and did that method. So I also don't recommend doing this as well. So this is just solutions that work every time. This is probably the most important part of this video that you want to listen to, is what is the solution to this issue? Because right now, all I've showed you is a bunch of failure, all the degrees or all the factors that get us to that point. So obviously, what is that solution? All right, so I don't think I can stress this enough, but dehumidifiers, dehumidifiers, dehumidifiers. I tell our technicians all the time, you need a dehumidifier. All right, so the solution is a dehumidifier. So adding a dehumidifier to an unconditioned area is you can control the dew point. So the way that works is you have humid air, comes through the dehumidifier, dries out, it drains outside, separate from the crawl space, and it pushes out dry air. And it just keeps recirculating until you get to that point of how much humidity you want in there. All right, so it's our job to size it, but it controls that environment. You really control the amount of humidity in that area. So if you have a duct system that's in unconditioned spaces, attics, crawl spaces, carports, we can't do anything about the outside temperature. The only time I get the chance to control that temperature or to stop the humidity from going in there is if you put a encapsulation around that encapsulated attic or just sealed up boxing. Otherwise, it's equivalent to putting a water pump in a lake, putting the hose back in the same lake and expecting that lake to pump out. The better the sealed up area, so as long as you don't have cracks and holes in that encapsulated area, the less the dehumidifier will run, which will be more efficient. Another question I've gotten before is, why is the ductwork even in here to begin with? In all reality, I 100% agree with this. Ductwork should always go into conditioned areas, which would be the house up here, because you wouldn't have any of these issues at all. Because up here, the dew point is less. It's about 50 to 60 degrees, like it is in this crawl space, but it's inside the house. And you don't have issues inside the house at all from the ductwork sweating. So if you could put it in the house, that would be the best option you could have. But a lot of times you don't have those options. Typically, it's a lot with the building, the framing of the house. A lot of times the framing of the house is not as easy as you can install ductwork, and it usually ends up putting a lot of boxing and it really looks ugly. So it's really aesthetic is the reason why a lot of builders on the Outer Banks don't put ductwork inside the house. All right, so that's the end of my presentation. Thank you all for watching and listening into this. Again, I'm Jane Schutzkoff. I work for RA Hoy Heating and Air. If you ever have issues, go ahead and give this number a call, and we'll be able to answer any questions that you have on this. Please don't hesitate to call us or email. You can email us at service@rahoy.com, and we'd be happy to help your condensation issue.